Alright, so here we're doing what we like to call a cliff problem because we basically have a cliff, someone's standing at the top of it. Now this person up here has, let's say, a ball, and they're throwing it straight sideways, straight horizontally at 11 meters per second. So we can write that down, VI equals 11 meters per second. We do not know how high the cliff is, but we know how far they threw it. So the distance equals 66 meters. And like I said before, the x and the y components are completely separate, so we can do the same thing with vectors, and we can make an x, y chart. And we'll do VI equals 11 meters per second. Distance in the x direction is 66 meters. And that's all we know, really. Alright, so if an object is held in place and then dropped, for that split second right after it's dropped, its initial velocity is still 0. So if we're in the y direction, our initial velocity is 0 meters per second. We don't know our distance, and the only component that the x and y share is time. So whatever the time is for x is the same as the time for y. And because in the x direction it's always a speeder, it's always going at the same constant velocity, the acceleration for x is 0 meters per second squared. And for y, we're just going to use the acceleration of gravity because that's all that's acting upon it when it's in the air. So negative 9.8 meters per second squared. So that's what we know. If we asked you how high is the cliff, you'd have to solve for distance. But to solve for this distance, you need another variable, and we can use time. And because x and y, the time is shared, we can find the time for x and then use that for y to find distance. So we're going to use the bulldozer here. So we have 66 equals initial velocity 11 times time plus 1/2 negative 9.8. Oh, no, just kidding, that's y. 0 t squared. Since we know this is 0, this whole thing just kind of cancels out like that, so we have 66 equals 11t. The time for x is 6 seconds. So now that we know that, and because we know that the time is the same for both of them, we can write in 6 seconds and 6 seconds. So now we have enough variables to solve for this, the distance in the y direction, which is how high the cliff is. So we can use this bulldozer over here. D equals 0 times 6, which cancels out because it's a 0, plus 1/2 negative 9.8 times 6 squared. Now when you multiply all that out, you get negative 9.8 times 18. And when you multiply that out, you have 176.4 meters. But really it's negative because it's going down. So that's how you would find the distance on how high the cliff is with what these given variables are. Yeah, just remember that the x and y are always separate, and the only thing that they share is time.